Hello everyone. Welcome to Controllerstech. This is part 2 of the tutorial on CAN peripheral, and today we will see how to communicate between two CAN devices. I have already covered the basics of the CAN protocol, and you must watch that video before this one. You can see the video on the top right. So let's start with this video now. I am using the BLUEPILL and the F446RE controllers, and the connection is as shown here. The RX and the TX pins from the transceivers are connected to the respective microcontrollers. Then CAN high and CAN low are connected with each others. Note that there must be a 120 ohms resistance connected at each node, just as it is shown in figure. Some transceivers have this resistance on the breakout board itself, and other don't. So make sure you check the resistance. Here is how the connection is. I have twisted the wire pair connected between CAN high and CAN low. You could try with simple wires, but if doesn't work, try twisted pair. Here is the 120 ohms resistance connected between the CAN high and low. I have it connected on the other node too. P11 and P12 from BLUEPILL are connected to the first transceiver, and the same pins from Nucleo are connected to the second transceiver. The transceivers are powered with 5 volts from the microcontrollers. This is all about the connection. Now let's start the project for the Nucleo first. So here we are in the CubeMX. First of all, I am selecting the external crystal for the clock. I have 8 MHz crystal, and I want the system to run at maximum 180 MHz. Notice here that the 446 have 2 CAN peripherals. As mentioned in the reference manual, the CAN 1 is the master CAN, and the CAN 2 is the slave CAN. Also they have 28 filter banks altogether. Let's configure the CAN 1. Now here I am going to set the baud rate to 500,000 bits per second. I am just modifying these parameters to get that. Here I got the baud rate. Now make sure that the operating mode is set to normal. And I am going to use FIFO0 to store the incoming message, so in the NVIC, I am enabling the RX0 interrupt. This is it for CAN setup. Now I am setting the PA5 as output for the onboard LED. Also, I am selecting the external interrupt for the user button, which is connected to the PC13. This is it. Now click Save to generate the project. I hope you remember things from previous video, because I am going to skip some explanation here. Let's write the program now. This is where the transmit header data will be stored. RX header will store the header from the incoming message. Let's create the arrays to store the TX data, and the RX data. And at last the variable for the TX mailbox. Now in the main function, start the CAN. Activate the notification for the data pending in the RX FIFO. Everything I am doing has already been covered in the previous video. Kindly watch it if you don't understand something here. After activating the notification, we will load data in the TX header. I am going to send 2 data bytes, so DLC is 2. We will be using standard ID. And the ID will be 0x446. This is the ID of F446RE. Whenever this controller will send the message, this ID will act as the ID of the sender. Now before I send data, let me explain what I actually want to achieve here. This controller will send the 2 data bytes. The first data byte will act as delay for the LED on the second board. And the second data byte will act as the number of times that LED will blink. When the second controller receives this message, the LED on it will blink according to these instructions. I am not going to send the data here, but instead let's send it in the XT callback function. When the user button is pressed, this function will be called, and we will send the data here. The delay will be 100 milliseconds. And the loop will be repeated 10 times. Now we will send the data using HOL CAN add TX message. Here we have activated the notification for the receive. When this controller will receive message from the BLUEPILL, a message pending callback will be called. Inside this callback, we will receive the data from the FIFO 0. The header will be stored in RX header, and the data will be stored in the RX data. Let's create a flag. We will just do one more check. If the data length is 2 bytes, then the flag will set. If the flag is set, we will blink the LED. The number of times it will blink will be the second byte of the RX data. And the time delay will be the first byte. And finally reset the flag, so that there is no false blink. Let's build it once. I think I forgot to enable the interrupt for the XT line. Let's enable it. Next we have to configure the filters. We will configure inside the CAN initialization function. Here is the filter configuration that I am using. Enable the CAN filter. I am assigning 20 filter banks to the CAN 1. Out of these 20, I am using filter bank number 18. This is the ID that should pass through. This ID will be assigned to the BLUEPILL later. And the same value in the mask ID register also. I am using FIFO 0 to store the incoming message. This configuration is explained in the previous video, so make sure you watch it. Let's build it now. Now since I am going to connect both the controllers to the same computer, I don't want the SD links to mix up. So I am going to assign the respective SD links to their controllers. Right now I have connected only the F446, and if I scan the SD link here, it will only show one. So we will keep this SD link assigned to this board. That's all for this. Now let's create another project for BLUEPILL. I am doing the basic setup, and running the system at maximum clock. Activate the CAN peripheral. We have to select the same baud rate here, that is 500,000 bits per second. Here I will use the FIFO one for receiving the message, this is just to demonstrate. PC13 is the LED on board, so select it as output. That's it, click Save to generate the project. I am going to use same code that I used in 446. So copy everything from here. We are not using the external interrupt in BLUEPILL. Let's copy this part now. Here we don't have CAN 1, or CAN 2, instead it's just CAN. As I said, I am using FIFO 1 here. So replace all FIFO 0 with FIFO 1. The transmit ID for BLUEPILL will be 0x103. Now let's copy the while loop. Here the LED is PC13. Now since we are not using the external interrupt here, we will send the data in this loop itself. Let's define the data that we will send. And after the LED is finished blinking, we will send the data using HOLAD-TX message. Now copy the filter configuration. Here the start slave bank does not matter, like I explained in the previous video. And the filter bank should be between 0 to 13. The ID that will be allowed to pass is 0x446. The ID of the F4 controller. Okay, this should be CAN. And we are using FIFO 1. Alright, it's correct now. So I have removed the F4 SD link, and now only the BLUEPILL is connected. If we scan the SD link, only one shows up, and we will assign it to the BLUEPILL. Now the code has been loaded into both the microcontrollers. Let's see if it works as expected. I have also connected the analyzer to see the data flow. Channel 0 is connected to the TX of 446, and channel 1 is connected to the TX of BLUEPILL. Pay attention to the LEDs on both the microcontrollers. The communication will start only when the button on the 446 is pressed. As you can see, when I press the button, the LED on BLUEPILL blinks for some time, and then the LED on 446 starts blinking. And then everything stops, until the button is pressed again. This is exactly what we programmed it to do. Let's see the data. This is the message sent by 446. You can see the ID, the control field, the 2 data bytes. Once this message is received by the BLUEPILL, the LED will blink, and once the LED finished blinking, the BLUEPILL will send the message. And here you can see the message sent by BLUEPILL. You can see the same process will repeat every time we press the button. Let's try changing the data for both of them. You can see the LED is blinking somewhat longer now. Also observe the message on the analyzer. There is almost a delay of 4 seconds here. We are sending the 100 milliseconds delay, and 40 times blink to the BLUEPILL, and that's why this 4 seconds. So this works pretty good. Now if you don't want to press the button every time, you can just send this data, after the blinking is finished. Just like we are doing in the BLUEPILL. This way the process will keep going forever, without any manual intervention. Let's run it now. I will start the process by pressing the button once. You can see the LED on BLUEPILL is blinking. And now the LED on the 446. And this process is keep repeating by itself. This is how we can use the CAN for the communication. We can send up to 8 data bytes at a time. Filters allow the message filtering at the hardware level itself, so the CPU don't have to do that work. This is it for this video. I hope you guys understood the CAN protocol, and how to use it for communication. Filter configuration is covered in the previous video, so watch it if you haven't watched it yet. You can download the code from the link in the description. Keep watching, and have a nice day ahead.